So, what am I doing? I've got a whole box full of weatherpack connectors, and then I've got weatherpack and metripack crimpers. All the Holley Dominator connectors are all these metripack, the flat connectors, the small ones, lower current ones, and then I'll be using these guys for, you know, other things around the hood. I probably will mix and match a little bit, but what I'm doing right now, because this is going to be sitting in the rain tray area beside the coils, and I've just ordered custom length Magnecore, what they call KV85, 8.5 millimeter custom plugs, custom made high voltage wire set. So measure the lengths and have a little runner, you know, clamping system for the ignition wires to make it all pretty. Anyway, it turns out that this all these cables, including the coils, are going to be right beside it. They all feed through the rain tray drip hole, and you know, these connectors are really close to the hole. And the way they've got this thing all taped up is all of these fuses and relays are kind of in the wrong position, let me put it that way. So I'm going to be, it's a very delicate operation, but I'm using an X-Acto knife to cut away all of the tape that they put on here, and then I can have individual wires running right to the connectors, and then I can make these things whatever length I want. I got, you know, 20 feet of wire here and 20 feet of power cable, and I'm going to need most of the power cable because I'm running a battery at the back, and this thing needs to go to the battery. But all this stuff is pretty close. I mean, this is only 5 or 6 feet max from all the sensors in the engine, so I want to get all this thing so that the wires are all exactly the right length. All these, I'm crazy, I know, all these harnesses for dozens and dozens of connectors are all unterminated. So I've got to make every connector, and I've got to build wiring diagrams, so, and do a bunch of testing, because I've got all kinds of sensors that I need to calibrate and test and make sure I get the pinouts right on. So we're into my phase of engineering that I like in metripack, because I am an electrical engineer that runs a software company, so this is my home zone. So this is sort of sensor madness. First thing, last time I was talking about the main Dominator ECU cable. I've stripped all of the tape that was wrapping this thing up, because I have to separate the individual wires, and they have a couple of relays and fuse blocks and things that I need to reposition just away from the ECU, just so it's easier to wire. This relay actually is both for the fuel pump and for the fuel injector power, so I'll have to figure out a good place for that, and same with the fuse. So on to sensors. So I'll just turn on my power, my voltmeter, and then turn on my 12 volt power here. So what I've got two sensors here. Let's just start with the speed sensor. So this is from a Mark III. This is a crap, no-name sensor that I found on eBay. It fits the original 020 transmission, and then a much higher quality. It's the same sensor, just it's a much nicer one, the Vimo sensor, and I've got all the part numbers. I'll put in the description of this video. But basically, I'm going to install this one, but I'm testing on this one. And basically, these sensors, this one of course doesn't have any markings on it, but the high quality one shows the ground, the 12 volt, and then the signal line coming out of it. So I can tell it's ground signal, and then 12 volts. And then these are all Hall effect sensors. So this is the crank position sensor I'll talk about in a sec, and also the cam position sensor. hidden in here. This is my custom unit, and this is they're all what's called open collector. So if you're not electrical engineers, what it basically means is a transistor, and when the signal is active, it's pulled low to ground, and when it's off, it floats. So if you tie it through a 1K ohm resistor to 12 volts, instead of it just, you know, picking up noise and just floating at whatever voltage it wants to, it'll snap up to 12 volts, and then so it's 0 or 12, 0 or 12. So these are all position sensors. So in this case, you'll notice as I spin this, so as I turn this, it will cause this. So if you watch the screen there, there's 12 volts. I'll turn it a little bit. It goes to 0. It goes to 12. It goes to 0. So as this rotates in the transmission, it just goes, you know, on off 0 12 0 12, and it tells the ECU that the transmission is spinning. I won't plug this in right now, but I've been verifying all the sensors. So I've got all the data sheets. I've sort of reverse engineered this. The original Mark III, the ABA block, comes with what's referred to as an inductive crank position sensor. So this is the guy. I've snipped the end off of it. The end's there. Sorry, that's the knock sensor. So just to verify, this has a shield line, and then it's like a speaker or a microphone. It has a shield line. I'm sorry, I got that wrong. A shield line or a ground line, and then it has this has oh no, that's right. So it has a signal coming out of here. It's an inductive signal. It's a sine wave basically. And this old school. It requires a circuit that interprets this and turns it into ones and zeros, or 0 and 12. This is a much more modern. This is actually from an Audi or a Mercedes. Same position. If you look at it, it's the same depth to it. Again, I'll have the part number for it. And this is a digital Hall effect sensor. So instead of an inductive sensor that gives you a wiggly, you know, low voltage signal that some, you know, analog circuit has to interpret and create a digital circuit for, this is an actual digital output, just like this sensor here. So this will provide an open collector output. I tested it last night. I won't do it again, but basically, you know, you connect this thing, and you'll as you bring a piece of metal towards it, it'll turn on. Piece of metal goes away, it'll turn off. So as the gears in the crank go by it, it gives a 1 and a 0, 1 and a 0, and that's how it knows where the crank position is. There's some missing teeth that'll tell you where top dead center of cylinder number 1 is. And then, of course, since the engine spins twice as a four-cycle engine, you need the cam position sensor, which spins half as fast, to tell you where the compression stroke is for cylinder number 1. Again, a Hall effect sensor, 3 pins, ground, high, and signal, and you need to have a 1K resistor for all 3 of these sensors tied to high, because they're all open collector output. So there you go. That's my story of the day. I spun this thing on my drill press. Just wanted to see whether or not it was perfectly balanced. I just had this little idea in my head that maybe I didn't machine this perfectly, and so I spun it up to 3,000 RPM, which is a little below 4,000 RPM, which is 8,000 RPM. Remember, the cam spins half as fast as the crank, so it seemed to be in balance. It heated up a little bit just because it's been rubbing a little bit against the Hall effect sensor, but that'll over time wear itself free. So yeah, it's this thing's going to work. So I'm happy. So I'm just verifying all the sensors here, and once I've done that, then I can wire up the car. So, you know, the 3 or 4 key sensors that are here are you know, really important parts of the engine turning on and running for the first time. And this massive amount of cable here is going to be cut to about 1/3 of the length. I'll mount the ECU, and then I'll start pulling wires in different locations and cutting them maybe a foot longer than they have to be, and then eventually terminating them with the right connectors. And that brings up the other thing, is that I had to search through the internet and find the correct, you can see in here in this bag here, the correct connector that will line up and match with this, and then the correct connector that lines up with this, and this is the last I'll talk about. This is the knock sensor, typical VW Audi knock sensor, and the output on this thing, again, I had to find a connector that would work with this. So every one of these connectors, or every one of these sensors has a different connector, and I had to figure out which one they were and find a source for it and order it and then be able to crimp onto it. So this has ground and then 2 signals. So it's pretty straightforward. It's a piezo sensor. As you bang this thing, it creates a voltage from the ceramic piezo element, and so one of the signal lines here is ground and the other 2 are signal. So I should be able to find out which ones they are relatively easily using the voltmeter, which is what I'm going to do tonight, and then I'll be able to note you know, which way to wire it up. And for a VW, it's 7.2 kilohertz is the resonant frequency we're looking for. So anyway, and that is Pico, my Burmese cat, who's trying to rip things up here. Yeah, yes, that's right. Into the car parts, young man. Anyway, there we are. Well, this is the definition of heartache. So VW Parts Place Inc. advertised on their website that they had original genuine VW Mark I Golf Rabbit glass for the French windshield, which is unheard of. So I phoned them and I said, is this true? This is exciting. And they said, well, there's only one catch. It's pickup only in Michigan. I live in the Pacific Northwest, so I said, money's no object. Hire someone to build a wooden box and ship this to me. So $400 for shipping later. This piece of Chinese glass with a non-stock tint is delivered. So I called them up and I went, you can't be serious. This is not OEM German glass. What is this? And they went, oh, you know, this is all we've got, you know, sorry. Anyway, so I don't like the tint across the top, so I'm going to make an attempt at building a 3/16 inch Margard. It's about a 5mm thick Margard Lexan window, front window. I've ordered a sheet of 32 by 60 inch material. I'm going to cut it out myself and then router the edges and then install it and see how scratch resistant it really is with the windshield wipers. I may end up having to put this thing in, but anyway, what a pain in the butt. I wanted to have the original glass, and I don't like the stripe across the top, as you can imagine, because it's totally not stock. Anyway, you lose some. That's a bit of a drag, but it is what it is. So these are my Magnecore KV85 ignition cables, and I've worked to build a cable harness that sits off the back and basically bolts to a couple of the bolts above the headers, and then it runs down, and I'm going to be pulling cables through that rain tray drain and into the ignition modules that sits beside the Dominator ECU. So I haven't finished mounting that plate. I'm going to put 2 bolt studs through the rain tray that are sealed, and then they'll pop up, and I'll put some nuts on that'll hold that tray in place with also some rubber backing. So that should work out nicely. Some of the cables are going to come down this rain tray, and some of the cables are going to run across and down the other rain tray and out, depending on what makes most sense. For instance, I'll bring the fuel injector lines here and then have a connector harness to the fuel injector lines, and the throttle position sensor and a few other things that are on the side of the engine. Then I'll bring other things down the other side there, and getting ready to do lots of this kind of wiring now. I'm kind of excited to get this engine started. So here's 2 different sets of wheels. Obviously the Snowflakes with the 185 6014s, and these are the Inky Racing 15x7s with the Hoosier A7 racing radial, which is basically a DOT approved slick, really meant for racing only, and it's a 8-inch, so it's a 205 50/15, but it's wider than most 205s, so it's a 9-inch cross section versus 7 for the stock wheel, so it barely fits. It's got like an 1/8 of an inch clearance on the inside to the springs on the back and 1/8 of an inch to the shock on the front. So it fits, but barely. I'm sure there's going to be some scrubbing if you go lock to lock, and of course it's not going to want the ride height to be too low. But it does, if you go above it here, it does tuck in. I'm not sure what it's going to do on the front, but anyway, that's going to allow me to go to the racetrack, do quarter-mile stuff and cornering, and just see what the maximum capability, because I have this is a race set of springs and shocks. They're pretty stiff, so I think that it'll basically be you know, work those tires to their fullest potential. So it'll be interesting to see the numbers we generate on this. So I now have this cam sensor positioned so that the gap, because the engine runs clockwise, which means on this side, sorry, clockwise from the pulley side, so it's counterclockwise on this side. So here, when the gap hits here, it gives it goes from 12 to 0 volts in the output. So 90 degrees before, which is 180 degrees before in the crank, because this turns half as fast as the crank, right? So this will turn 1 revolution for every 2 engine revolutions, and I want to fire the cam sensor 180 degrees before top dead center on cylinder number 1. So this whole thing is set up right now to be top dead center compression stroke cylinder number 1. So I've now got the gap, which is just, you can feel it, it's right underneath there. So it's the leading edge is going to hit 90 degrees, boom, it'll hit the sensor here, and then trigger the computer saying, okay, top dead center cylinder number 1 is coming up, and then cylinder number 1 will actually be determined by the crank sensor underneath. So it's a 60-2 tooth standard crank sensor. Here you can see there's top dead center, there's cylinder number 1 mark, because again this thing will spin this way, clockwise, and then if you look down at the bottom, can't really see it very well, but down right here on the crank, it's also at 12 o'clock on the harmonic balancer crank pulley. So we're all set up for the correct timing, and then, oops, I'm stuck on there, and then the ignition system will be able to test fire with the fuel injectors disconnected, and test fire for each of the spark plug wires with a timing light, and make sure that we're getting ignition to each cylinder at the right time. This is called a waste fire system. So you've got cylinder number 1 and 4, 2 and 3 paired, and basically when you're on the exhaust stroke, the other cylinder is fired and it's just a wasted spark. But so you use 2 coils and direct drive off of the ECU, and so 1 and 4, 2 and 3 are paired, and that's the way it works. So I'm going to do the last sensor test now, which is the actual crank sensor, because I've swapped the inductive sensor for a Hall effect sensor from a later car, from a Mercedes. So down in the hole down in there, I will stick the sensor, and I will turn the engine, and I will see if I get the correct 12 volt, 0 volt output as I go by the teeth. Well, not so fast. So this is the original inductive crank sensor, and this is the Mercedes one. Well, it's a Bosch, but anyway, yeah, this right angle connector here, it's too close. This connector hits the block, so I still want to use it, so what I'm going to do is I'm going to cut the connector off, and then I'll epoxy on a new pigtail that comes straight out, and then I'm going to have to profile. This is a big rounded end, and it looks like I'm going to have to profile it so that it's a little bit more tapered, so that it'll go up against the block. I mean, it's the right depth. It you know, it should work, but I'm gonna have to fuck around with it. Anyway, all right. I knew this would be a challenge. Also, I had to pull the oil filter out. I could not get my fingers in there, and scrunched up a nice new oil filter. So $2, boo. So the Holley system uses metripack, which is the flat blade connectors, and then the easier ones to work with are the older weatherpack with the round connectors, the round pins. They're available in different crank carry capacities, but kits are just a little bit easier to use. Everything's a little larger, but this is a sample kit from DIY Auto Tune, and it's 1s, 2s, 3s, 4s, 5s, and 6s. It's kind of nice. Anyway, so I had to modify the crank sensor, sort of cut it down, and change the way the pins come out. So I'll epoxy pot this in epoxy, but basically there's the sensor prepped, ready to go in with the weatherpack connector. And I'm going to install that and test it now, and hopefully it works. And then after that, I'll put it in permanently. I'll epoxy it, and then it'll go into the engine permanently. And then I'll be ready to roll. Well, it's late at night, and anyway, I finally got that crank sensor in there on a temporary basis, at least. It wasn't sitting flush, and I ran some tests. So there's an oscilloscope, and basically those wiggles, there are 0 to 12 volt output from the Hall effect crank sensor. So verified that when I turn the crank, I get pulses like I should. So anyway, a huge amount of work tonight, but I got it done. I just have to make sure that when I install it, it's leak proof and it seals solid, like it's like in flush. I was having trouble getting it in flush, and I've removed the O-rings from it to get it to go flush, but when I put the O-rings back on, I'm going to have to really push hard to make sure it seats. Maybe I'll use RTV instead. I'm just going to have to think that through. So anyway, that's the last major engine sensor, and I'm happy that it's functioning.